So proportionality using graphs and tables. So if you look at this, proportional relationships, and you can just listen to this. You don't have to necessarily write all of it. If I highlight it, then it would be good for you to write it. So you can use you're going to use your knowledge of ratios and proportions to determine if there's a proportional relationship. Relationships are usually represented using a graph or table. And we use the graph or tables to test. So in order to determine if, sorry, I decided to get a blank paper. In order to tell from a table if there's a proportional relationship or not, you can check to see if the ratio y over x, or y, remember that symbol means y to x, is the same. That's just ratio. It means the same thing as y over x. So if you ever see y with those x, it's just y divided by x. So the y over x, or yx, is also known as the constant of proportionality. So you should write all of that, and those are two separate things. And you should also write this, the constant of proportionality. And I'm gonna tell you another name for that in just a minute. But so the ratio y over x, or y to x, is also known as constant of proportionality. So you must reduce the ratios. So if you have something like 8 over 4, 8 divided by 4 is the same thing as 2, so must reduce. Sorry, that's really little. So 8 over 4 would equal 2. 8 divided by 4 is 2, so you must reduce. Okay? When the relationship is proportional, or when the slope, or the relationship is proportional when the slope is equal to the ratio. So slope equals the ratio, or the constant. Constant of proportionality. Okay, so slope, change of y over change of x, remember that is slope, is equal to y divided by x. So let me show you what that actually means now. So if we have a table, you're going to take y, and I'm going to use two different color highlighters, so make sure you borrow a highlighter if you need a highlighter. But so you're going to take y, and you're going to divide it by x. So each time you're going to do y first, so notice it's y, all of the y values, divided by the x values. So we took all of the y and divided by x. So 10 divided by 5 is 2 over 1, which is just 2. 16 divided by 8 is 2. 20 divided by 10 is 2. 28 divided by 14 is 2. 42 divided by 21, that's a little bit harder, but if you type it in a calculator, that would also be 2. So this is a proportional relationship because y over x, all of the ratios are equal. The constant of proportionality is 2. Okay, so this one is proportional. So you typically will have to find the ratios here, and then since all of those ratios are the same, it is proportional. Okay, then we're going to do the same thing. 9 divided by 6 which is 3/2 or 1.5. And I'm just going to go through and highlight all of them. Oops, that does not say the right number, does it? So that should say 44 over 22. 21 over 14. Sorry, mistakes. Okay, so then keep highlighting those. I'm trying to find my calculator over here. And then so you get 3/2 or sorry, I'm getting my calculator because my personal calculator was dead. So 9 divided by 6 is 1.5. 15 divided by 10 is also 1.5. 20 divided by 4 is 5. So you can see that since that one is not, since they are not equal, it is not proportional. And then if we do 21 divided by 14, that's 1.5. 44 divided by 22, that's 2. So I just had the wrong numbers. I just didn't, but I had divided them right. So these are not proportional because these are not equal each time. As soon as there's one that's not equal, it's not proportional. So then let's see for these following ones. So if I take 4 and I divide it by 1, so 4 over 1 equals 4. Eight over 2 is also 4. But then you get the one that does not work. So it'd be 9 over 3. And type that in. 9 divided by 3 is 3. So this one would be not, because these are not equal. Okay, let's try the next one. So we said 6, 9, 15, 4, 6, 10. So 6 divided by, oh, sorry, you can't see it. 6 divided by 4 is 1.5. 9 divided by 6 is 1.5. 15 divided by 10 is 1.5. So this one is proportional. Since they're all equal, it is proportional. Okay, remember a ratio can also be represented as a decimal. Sometimes you'll see it as a fraction reduced, but you can also see it like you could see it as 3/2. halves, or 1.5 will also work. Okay, using a graph. So make sure write using a graph. So if you're looking at a graph, you can test proportionality by looking. It has to go through the origin. This is one of the most important things. It has to go through the origin. And then, of course, it has to be a straight line. So constant rate. Okay, so those are the two questions you need to ask yourself every time you look at a graph. So if you look at this graph, it is a straight line, and it passes through the point 0, 0, so it's proportional. And that's it. If you're given, the graph is actually the easiest way. You don't have to do any division, you don't have to do anything, because if we were looking, so we could take 5, we could look at these points, and you could divide them. Like you could say 5 divided by 6, and then the next one would go up to 10. So this one would be 5 divided by 6. Ah, 5 divided by 6 is 0.83. And then if we continued this same constant rate, it would be up here at 10 over 12, which would also be 10 divided by 12 is the same number, so 0.83. So again, it has to be a straight line because it has to keep going up and over the same amount. And then it has to go through the origin. If it was slightly up, then this number would not be the same ratio. Okay, so yes, it's a straight line, so that works. It does not pass through 0, 0, so it is not proportional. And again, we could see that because if we took this point right here and did 3 divided by 2, I just took the y value over the x value, y, x, and then I divided by 4 over 4. 3 over 2 is 1.5, 4 over 4 equals 1. So that is why it doesn't work. So for those two the two ratios to be the same, it has to go through the origin. So, but again, it's as easy as answering those two questions. Yes, it's a straight line, but it does not go through the origin, so it's not proportional. Okay, this next one, if you're looking at ordered pairs and to tell if the ordered pairs are proportional, take the ordered pairs and make the ratio y over x. So again, these are y's. These. And then so 4 divided by 8 is 1/2, or 0.5. 10 divided by 2 is 1/2, or 0.5. 5 divided by 2.5, that one's a little bit harder to think about. Or sorry, I'm saying that wrong. 4 divided by 8, 4 divided by 8 is 0.5. 5 divided by 10 is 0.5. 2.5 divided by 5 is 0.5. And 6 divided by 12 is 0.6 divided by 12 is 0.5. And so, of course, this is proportional because all of these are constant. Some people don't like to look at it as an ordered pair, so this next one just shows those same points written in a table. So whichever way is easier for you, you could look at it in points like this, or you could take those points 8, 4, 10, 5 and put them in a table. Okay, almost done. All right, now To determine if an equation is proportional, identify the slope and y-intercept from the equation. If the equation has a y-intercept of 0, of course that would mean it's going through the origin. Because if we think about y-intercept, if the y-intercept is 0, it's going through the origin. So this one, the y-intercept is 1, because that's the mx plus b. So the 1 is the y-intercept, so that would mean it would have to cross right here. So that would be not proportional, because remember, it's got to go through the origin. Okay, then this one, since there is no plus b, you could think of it as plus 0. So that would make it proportional. 10 would be the slope, and the 0 would be the y-intercept. And then again, remember you've got to go through the origin, and then you have to have a slope like that. So it would be 3 over 1, 3 divided by 1, 6 divided by 2. So there you go. That is proportionality using graphs and tables. Remember, your biggest thing you want to look for is that it goes through the origin and it has a constant rate. And you find it by dividing y over x.